Hi my dear friends, welcome back to our YouTube channel ADC Max. Hi, how are you? I hope everyone is fine. Please try to take care of your health. Stay safe, stay happy, stay healthy. This video lecture will give you the application of the inversion formula for the Fourier sine and cosine transforms. So only on the board, Fourier sine transform of e to the power minus ax, e to the power minus ax. Suppose if I am considering the f of x equal to e to the power minus ax, the answer is s by s square plus a square. So cosine transform means a by s square plus a square. In front of that root 2 by pi, right? And the corresponding inversion formula, because as you know that the transformation is between the two sets, that is the input is f of x, and the Fourier transform we get it is f of s. So the same case under the Fourier sine transform, so this is the f of s. Once this exists, the inverse is possible. So for the inverse, what's the inverse? The inversion formula is the input is s, the outcome is x. So this is the inversion formula. The input is s. So root 2 by pi integral s equal to 0 to infinity fs of s sin sx ds. So s is the input function, the outcome is x. Similarly for the cosine transform, the input is s, the outcome is x. Right? Now by using this inversion formula for the Fourier sine and the cosine transform, I want to evaluate integral 0 to infinity x sin sx by x square plus a square dx and integral 0 to infinity cos sx by x square plus a square dx. Yeah, we can do this integrals already in the use of with the help of the contour integration under the complex integration, isn't it? The last semester, the previous years, you may solve this type of integrals, indefinite integrals, the evaluation of the real definite integrals by using the contour integration concept, but the contour integration is by using the Cauchy's residue theorem. Cauchy's residue theorem nothing but 2 pi a into sum of the residues of each of its poles. Please go and watch. Already made a separate video for the complex integrations. Please go and watch it. But this time I don't want to go to those techniques. I don't want to go for the complex integration or Cauchy's residue theorem, nothing. No. I want to use the Fourier transforms. But it is the question is very simply given, evaluate the integral, that's it. So you can do by any method. But this time I want to go by the Fourier transform, particularly the first one is sine was there, so I use sine transform. Cosine is there, the second was I use cosine transform. So what is sine transform? Sine sx, yeah, sine sx, cos sx is also cos sx. Yeah, I think similar patterns are there. In front of it I have x here, there is no variable here. Yeah, when we get x in the numerator, when we get the variable in the numerator, it is for a sine transform of e power minus ax, right? And there is no variable in the numerator, only the constant, then it is comes into the cosine transform category. So here I suggest you that can you take f of x is equal to e to the power minus ax, where a is a positive constant. So by using the Fourier sine transform of e to the power minus ax, already we know root 2 by pi s by s square plus a square. Can I use the inversion formula? So by using the inversion formula for the Fourier sine transform, what happened? F of x in the numerator is the left hand side, the right hand side is this one. So root 2 by pi integral 0 to infinity fs of s. What's the fs of s means? It is s of e to the power minus ax into sine sx ds is equal to f of x e to the power minus x. So I can substitute the f of x is equal to e to the power minus ax in the left hand side and right hand side. Right hand side fs of e to the power minus ax. So what's fs of e to the power minus ax? This one. So is equal to root 2 by pi integral 0 to infinity. What's the Fourier sine transform e to the power minus ax? Is also one more root 2 by pi s by s square plus a square. So this is the value for this one. This is already there in the book. Sine sx ds is equal to e to the power minus ax. Very simple concept, you see. Root 2 by pi, root 2 by pi is 2 by pi, that's right. Integral 0 to infinity s sine sx by s square plus a square into ds is equal to e to the power minus ax. Please see that we almost reached the answer. See, almost reach to infinity, s to infinity. Here sin s x, sin s x. Here yes, here yes, here x, here x. So replace that variables mutually. So replace the variables mutually x and s. Replace x and s mutually. If you replace x and s mutually, the left hand side 0 to infinity, x in the place of s equal to x, sin xs or sx, no problem. By s is equal to x, x squared plus a squared into d, s is equal to x is equal to e to the power minus a, x by s. Now this 2 by pi becomes pi by 2, so it is pi by 2. So the answer is pi by 2 into e power minus as, where a is a positive constant. Yeah, right? Because as I see that the input is x, so the outcome is obviously s only. Yes, correct. That's it. Because after integrating with respect to x, after integrating this with respect to x, the outcome is s and a. Yeah, that's there. Over. What about the second one? Yeah, cos sx. The same concept, taking f of x to the power minus ax, using the inversion formula for the cosine transforms, we'll get the answer. Yeah, what is that? The left hand side root 2 by pi integral 0 to infinity for a cosine transform of f of x is equal into cos sx ds is equal to f of x. What's f of x now? I'm going to consider f of x the same, e power minus ax. So root 2 by pi integral 0 to infinity for a cosine transform of e to the power minus ax, e to the power minus ax into cos sx ds is equal to e to the power minus ax. Already we know the Fourier cosine transform of e to the power minus ax is root 2 by pi a by s squared plus a squared. So can I substitute here? We get root 2 by pi integral 0 to infinity square root of 2 by pi a by s squared plus a squared into cos sx ds is equal to e to the power minus ax. As I told you that, just replace this with the help of this result. So root 2 by pi, root 2 by pi is a constant, so 2 by pi, a is also a constant, so 2a by pi coming outside, is right? The balance is 0 to infinity cos sx by s squared plus a squared into ds is equal to the power minus ax. Once again, almost we reach the answer, but in the place of s is equal to x, in the place of s is equal to x. So replace x and s mutually, we get integral 0 to infinity cos sx by x squared plus a squared into dx is equal to, because s is equal to x is equal to x. Here s is equal to x, x is equal to s, because mutually, I told you mutually, is equal to. Now 2a by pi, this comes reciprocal, pi by 2a, e power minus a. What about x now? Yes. So anyhow the output is s only, because after integrating with respect to x, the outcome is s and a. Yes, right. See that this is the beauty of this property, inversion formula for the Fourier sine and cosine transform. So this is the concept. After getting this one, it's possible to get the value of, for example, in the competitive exams, if you have the question like this, suppose tell me what is the value for integral 0 to infinity x into sine 2x by x squared plus 9 dx. Yeah, tell me how is it possible. So we can do this by contour integration or complex integration or some other techniques in the complex integrations. But I don't want to those method now, because it is a very easy one once if you know this transform techniques. When you compare this, what's the answer? Pi by 2 e power minus ax. No, when you compare, what is the s value here? Here s is equal to 2. Here s is equal to 2. What about a squared? A squared equal to 9 or a equal to 3. So this is equal to pi by 2 into e to the power minus a into s. A equal to 2 is 3. S is equal to 2. So 3 into 2. So the answer is pi by 2 into e to the power minus s. So we get the answer just a fraction of a second once we know the result. Similarly, suppose the question is, this may be the competitive exams, you may go for the competitive exams, evaluate the value of this integral is this much, so a, b, c, d. So what about cos 4x by x squared plus 25 into dx? Just you can use this technique. Here what about the s value? S is equal to 4 and a is equal to 25. It's a squared equal to 25, so a equal to 5. So by using this idea, pi by 2 into a, 2 into 5, e to the power minus of a equal to 5 and s is equal to 4. So the answer is pi by 10 into e to the power minus 20. So that is the answer. Very simple, just a fraction of a second in a single line. When you get the answer, if you know this result. But this is with the help of the inversion formula for the Fourier sine and cosine transforms. Got it? Understand? So you see how the Fourier transform is applied in many areas, in the many types of integrals. We are not knowing these techniques in the lower classes, but now we know after knowing the Fourier transforms. That's the beauty of this Fourier transforms. Thank you. Thank you so much for watching our YouTube channel. Please kindly support our YouTube channel ADC Max. Thank you. Thank you so much. Take care. Bye.